Good morning. I am Devi Abhirami, Assistant Professor, Department of Mathematics, Dr. SNS Rajlakshmi College of Arts and Science. Today I am going to explain. The topic test of hypothesis, small sample test, t-test. In the previous video itself, I have explained the t-test, how to calculate the t-test, and I have also explained about the t-test formula and the null hypothesis, alternate hypothesis, and all. Here I have given the problem directly. A manufacturer claims that an average lifetime of LED bulb is 5000 hours. A sample of 10 bulbs gives an average lifetime of 4800. So here we can claim our population mean is 5000. That is denoted as mu is equal to 5000 and average lifetime is denoted as x bar. So x bar is equal to 4800 with the standard deviation is 300. Now I am going to using a small sample t-test. I am going to calculate the t-test statistics value. So in the previous video itself I have explained the t-test formula. T-test formula is nothing but t is equal to x bar minus mu divided by s by root n. Sometimes they have given the standard deviation as s, or sometimes they will give us sigma. Okay, here my value is 4800 minus 5000 divided by yes is nothing but the standard deviation is 300. Here the number of observation is 10 bulbs, so divided by root 10. So if I simplify it, I will get the answer as minus 2.11. Here also we can find the degrees of freedom. So degrees of freedom is nothing but n minus 1, that is 10 minus 1 is 9. My second problem is in a data science project analyzing employee performance, sample of 16 analysts. Therefore, the sample of this problem is 16. Therefore, the n value is equal to 16. Average daily output is 42 reports. Average means we will denote it as mean value, that is x bar is equal to 42, and their standard deviation is given as 3.8. So S value is 3.8. Sometimes S or sigma. We can take any one of that. The industry standard mean output, so the population mean is given, that is mu is equal to 40. Now I am going to compute t-test. From the t-test I am going to analyze whether it is one level of significance exceed the standard or not exceed the standard. So now I am going to formulate the hypothesis. The one is null hypothesis, another one is alternate hypothesis. So null hypothesis is nothing but the population mean should be equal to our assumption. So mu is equal to 40. If it is not, that is if we rejected the null hypothesis, then we have to accept the alternate hypothesis. Alternate hypothesis is obviously we have to take greater than 40. So by using the t-test formula, I am going to apply my values in the t formula so that I can get the t value. From the t value I can conclude whether the null hypothesis is accepted or rejected. Okay, my t value is 42 minus 40 divided by 0.95. If I divided it, I will get 2.11. They have mentioned that critical value in the problem, in the question itself is 0.1 percentage. That means 0.01 percentage. So the critical value for a t-test of 0.01 percentage is 2.602. So if I compare it, my answer is less than the critical value. If it is less, we can accept the null hypothesis, what I have explained in the previous video. That is, if the null hypothesis and our critical value is less than our calculated value, then we can accept the null hypothesis. If we accept that value, then we can reject the alternate hypothesis. So, I can conclude there is no exceed standard employee productivity analysis for the given set of values. This is how we have to calculate the t-test, and we can conclude this solution. My third problem is a marketing team test a new campaign by surveying 20 customers. So 20 customers means n value is 20 and their average means x bar is equal to 7.8, standard deviation s is equal to 1.2, and the population mean is mu is equal to 7, and the significance level is 5%. 5% means 0.05 percentage. So our question is whether determine the campaign has improved or not. So to improve, the population mean should be equal to 7.0. If it is not, then it is greater than 7.0. That is our population mean. So for this also I am going to calculate the t-test value alone by using the t formula. So if I calculated it, I get the answer as x minus mu divided by s by root n. X value is 7.8, mu value is 7.0 divided by standard deviation is 1.2 and the total number of customers is 20. Okay, so if I simplify it, I will get 2.11. What they have told, that is 5%. 5% critical value is 1.729 from the table value, but our calculated value is 2.99, which means it is very greater than our calculated value. Hence we can accept the null hypothesis, we can reject the null hypothesis and accept the alternate hypothesis. Therefore, there is a significantly improved customer satisfaction. So there is an improvement in the customer satisfaction. This is how we have to compare the null hypothesis and the alternate hypothesis, and we can conclude with the solution whether it is improved or not. Thank you.